May I now request Dr. Ninad Mendere sir to take over this session.
Thank you, madam, for the introduction. So I would like to start the session by sharing a screen. And today we are going to talk about something related to the sensors with deep learning in autonomous vehicles. So without wasting much time, let us start with the talk. When we heard this topic, first thing we should understand is what is autonomous driving. So a driver should able to just sit back, relax, and the car should automatically navigate him through with the help of some sensors and a deep learning technology. So this is one example where Tesla's car is on autopilot mode, and you can see how efficiently it is driving the car, and driver is doing nothing. This kind of autopilot mode we might have seen in planes, but for planes this technology is there because of its ease. In play, when you are in air, you don't get the cars, pedestrian. At max you get some birds, and there are some incidences where autopilot planes do hit birds and killed them, but nobody cared about them. But when we see a human driver, we can see that it's totally optimized. A human can drive through any scenarios with whatever speed he wants. And we need to create a technology that can challenge this ability of the humans. So there are different levels of automations in a car. We call level 0 where there is no automation. Then there is level 1 where this car can handle one task at a time, like automatic braking. Then there is a level 2 autonomy where cars would have at least 2 or more automated functions. Then there is level 3 autonomy where dynamic driving task. You might need a human intervention in that, but mostly it's dynamically driven. Level 4 autonomy is these are basically a driverless cars, and they can allow user to sit back, relax, and user don't have to intervene. And the last one is where you don't have a pedal or accelerator, means you cannot do any human intervention, and this car completely operates entirely in a driverless manner. So this kind of system you might have seen in some of the airport metros where people just enter, there is no driver to that metro, but you can imagine that has a track and nobody is gonna get interfere in between those monorails. So that's why level 5 autonomy is possible over there. But when it comes to the car on the road, there are a lot of obstacles. So to summarize, basically we have total 5 levels of autonomy. The first 3 levels requires driver support, and here level 0 you can have simple warnings or automatic emergency brake or blind spotting, at the back when you are taking a reverse, it might give you some alarm indication. Then in level 1, steering or brake, either of them is getting controlled. Lane centering is there, means obviously in India we erase the lane lines, and it is very difficult for us to find any lane centering. But in abroad country where the population is less and roads are more with proper white lane lines, then lane centering is possible. Adaptive cruise control is also possible, but for our country this is more of a need rather than just a facility. Then steering and brake at level 2, they are going together along with lane centering and adaptive cruise control. Now level 4, level 3, 4, basically they can tackle with the traffic jam and other local driverless taxis. So they have to work in synchronization. There a high speed communication is needed. And then finally a dream of every car company to have a level 5 autonomy. This is same as level 4, but this time driver cannot do any intervention. So you have to remove the car steering and brake control, and you have to completely trust the technology. So these are the 5 levels in which we want to work. Currently the technology has reached up to level 3, and some parts of the country have reached up to level 4 also. In India, we are still at level 1 or level 0, you can say. Now, this is the expected projected market towards the autonomous vehicle. Currently, in 2022, it is about 0.17%. And by 2030, we expect this market to grow at least around 12%. So 12% of the cars on the road in next decade will be mostly autonomous. Now, what are the sensors in your autonomous vehicle? So this is the talk we will focus on. Basically, there are radar sensors, then there are LiDAR units, cameras, additional LiDAR units, and there is a main computer. So they are indicated by different colors on the car and where they are placed. So typically there are 4 types of autonomous vehicle in self-driving cars. So 4 types of sensors are camera sensors, which can see or give the eye to the car. Then there is a radar sensor, which sends the electromagnetic pulses and then receives them back. Then there are LiDAR sensors, which sends the light pulses and receives them back. And then there are ultrasonic sensor, which sends the sound signal and receives them back. So how does a car see? Camera is the thing through which a car can see the people. So typically it's not a single camera. There are always multiple cameras involved. Either they can be a stereo vision camera or they could be a regular camera. Now, for those who don't know about stereo vision, I just try to explain. Let me just take the pointer. Okay, so basically you put 2 cameras at a spacing of 6 to 7 centimeters from each other, and then these 2 cameras image are combined in a way that it can give you the sense of depth also. So basically we have to do edge matching, and then we have to overlay the images, and based on the distance delta, we have to find how far the object or how close the object is. If the object is far, the most likely both the images will overlap from both the cameras, and if object is nearby, then there will be a lot of difference between the 2 images, and that can give you the sense of depth in a stereo camera. Now there are 360-degree view cameras also available. Typically these 360-degree view cameras have a oval kind of shape, and they can capture light from all directions, and that's why they are called 360. They still cannot capture a spherical image, but you can imagine 360-degree in one plane. Okay, so whenever we say it's a 360-degree view camera, that means we are talking about one plane, and the other plane, which we call a solid angle, can go up to 120-degree. In some of the cases, it has also crossed 180-degree. Now, most of the cameras that we put onto the car needs to do a live object detection. So for that, we need a very high computing power. Typically, NVIDIA produces Google or NVIDIA or Google, 2 big companies are producing these boards. They're called PIX boards or AGX boards. So these boards cost anywhere around 1 lakh to 1.5 lakh, and some of the cases it can cost you around 20 lakhs also. So pretty costly technology, but pretty accurate also. So you can see here a image is given to this technology, and it can detect with certain confidence level that this is 97% car, or this is 99% traffic signal. And based on this training, this accuracy can be improved. Yes, Dr. Joshita, I think you are unmuted. So can you please mute yourself? I think I can mute her. Okay, thank you. Okay, so next is, I think this is a small clip about live image processing. I think it will get played now. Okay, so you can see this is how a camera's live image processing work, and it is trying to segment the road from the possible obstacles. Completely sure possible obstacles are shown in red, and possibly in between are shown in blue and yellow. You can see how this car is detecting the objects in real life with possible driving navigation. So this is the kind of processing power we need in real time if you want to do anything with the camera. So again, what will happen to the cameras in the night? So this is another video that shows how car can see in the night. So this is a completely dark road. So this is how your regular camera will see the things. And this is how a night vision camera will see the same road. So it's even with the headlights on, it's really difficult. But with the night vision camera, you can see the animal is standing. So see, if you try to do a decision making based on this, you will see the animal at every last minute, and that's why it's not possible for computer to take a sudden action and it will cause a lot of damage. But in the thermal camera, this deer was visible from the beginning itself. So it is important to not just to have a stereo camera, not just to have a 360 camera. These cameras should not have any IR filter on it. So typically when you buy a camera, it comes with a onboard IR filter that can block all the infrared light. But for night vision cameras, this infrared light is most important information. So you need a camera with no IR. Such cameras are available at the cost range of 2000 rupees onwards, and you can easily buy them in the market. Now, this is the way you can capture a 360-degree image. They all look spherical, and they also suffer from something called a spherical aberration. So this is how a 360-degree image looks, and this is how the 360-degree camera is mounted on top. Typically, you need a complete glass window to capture all the light. And then once the image is captured, you need a lot of geometry, and you have to expand them using multiple Pythagoras theorems. And then you can put these pixels at the correct orientation with the correct angle, and then you can scale them. So this is how a 360-degree camera sends the signal. It has a mirrors on the top to capture the light from outside. This camera captures light from all direction, and they put it through this particular hole at the top. So we generally assume you're having a fisheye lens, but for the 360-degree cameras with the cars, we need a mirror based system so that you get a complete information. And yes, there is a blind spot, and these are the blind spots which are very close to the car objects. So for that, we need a secondary set of cameras. Then you have an obvious solution of fisheye camera. Now, those who don't know about fisheye camera, basically it is derived from actual fish's eye. So fish has two eyes from the opposite end, and it can see the two different images from both the eyes, and still it can merge and make a sense of out of environment. Same principle has been implemented into such lenses where you get a completely circular image, and this way you can see 360-degree. So we human can only see around 120-degree, at max 150-degree, but a fish can see with its one eye 180-degree on one side, and the other eye can allow him to see 180-degree on the other side. So basically fish has a complete knowledge of 360-degree, and that's why even if you're coming from the back, he can easily sense you and save itself. So that's how these animals can see that there are many such animals who can see 360-degree, and this principle has been imported into the camera. And in autonomous vehicles, this is very important because you need a complete surrounding information. Then, as I mentioned, night vision camera allows you to see the things in the complete darkness also, because of the passive infrared heat coming out of a living body, as well as the infrared transmitter is there. So you can see night vision camera always come with this LEDs which never glow because we can't see them glowing. They are the infrared LEDs. They are continuously sending the infrared signal out, and then the camera only can see it. So it's kind of a spooky or a ghosty effect where night vision camera can see the things which we can't. Then comes a very important camera sensor mounted on a car. It's called a stereo depth camera. So as I mentioned, stereo camera has a spacing of around 6 to 8 centimeter, like we human have between the two eyes. This camera has two cameras, two regular RGB cameras. Then it also has a IR projector for the night vision. and it also has a regular color camera to overlay the images with respect to one reference point. So these typically cameras are sold by Intel. They are called Intel RealSense, and the cost of such depth cameras may range from 20K to 40K depending upon where you are purchasing it for. So you will see there is a lot of versions. Even if you purchase a module, you can get it around 3.5K, which is very cheap compared to any other camera module, and you can get the depth information along with this particular camera. Then the second most important sensor. So we talked about different types of camera systems. The second most important sensors in the car is a radar. Now radars are the conventional systems used by the military to detect the missiles and planes also. They basically send out the signals, electromagnetic wave, and they are the antennas which receives them back, and based on the time of flight we can calculate the distance of object. So basically a electromagnetic wave is sent, it hits the object, and then it is returning back. So based on that you can measure the signals time of flight and then divide it by 2, because one half of the time is for transmitting and half of the time for the receiving, and then based on the speed of an electromagnetic wave and time it required to receive back the signal, you can calculate the actual distance of object. And that's why the rotation speed of a radar is also very important, because there is a phenomena called Doppler shift that shifts the frequency based on the distance of object. So you can use that also to cross verify whether the object is correctly detected or not. So it's a very popular technology, but the radars used in the car are of different wavelength. They are not the same as your military radar. They typically use 77 gigahertz access. So there are two types of radars used. One is LR radars, which are called long range radar, and they are typically mounted on front of a car so that you can sense a long range from the car. And then there are some short range radars to cover the blind spots. So typically these short range radars are connected at the sides and at the back of the car. So if some object comes suddenly closer to the car, these radar sensors can give the information. So these are the MR and SR type radars, and these are called short and medium range radars. Now the typical mounting of the radars is, as I mentioned, the front has the maximum range, as well as some medium range radars at 45 degrees from the back, and then you have a back radar which is again a longer range, and then you have a very close vicinity radars which are just covering few millimeters from the car. So long range radars are typically high resolution and they are costlier also, but we have to have these radars. So we have a first sensor which is camera, which is giving some piece of information with help of depth sensing. Then that depth is cross verified with the help of a radar. Now there are different generations of these radars being developed, so you don't see a bigger antennas rotating around continuously, but the radars here are very, very small, and they look like a small what you can say, they are of a size of a mobile phone, and they shine on one side. So they have this radar dome through which it can send the light at different electromagnetic waves at different location. And then you have actual a PCB of a radar over here, and then you have some metal casing or a plastic casing depending upon what cost of this radar you are using. And obviously then there are some signal processing, signal conditioning and DSP circuits mounted on top to process the data. And then you finally have a 9-pin connector which can directly connect it to the computer. So no radar data processing is done onto the computer. Everything is done through this chip. It's on chip processors, and that's why the cost of these radar sensors are very high. Typical cost of any radar sensor would lie from 1 lakh rupees to 11 lakh, and based on the range and type of the radar you can select the one. So this is how a radar signal sends information, And this is a long range radar, so it automatically detects the next car and it can slow down its speeds or control it dynamically. And then the most important sensors with respect to the autonomous vehicle, it's called LiDAR. Now LiDAR is basically similar to the radar, but they sends a visible laser light. Uh, you generally don't see this laser, right? Some of the LiDARs do send a red laser, but typically they are infrared lasers, so you cannot see them with your eyes, but other photoreceptor can sense there is a LiDAR moving around. So these are the things that actually gave the ability of cars to drive self in autonomous mode. These gives you the complete 3D environment around it. Typically, these uh, LiDAR sends a signal in either 16 directions or 128 directions. So you have actually an array of 128 laser light sending light at different frequencies at different angles. So that's how it can get a 3D information. Now, obviously, the Z direction information is not up to the mark, only 128-bit resolution in that. But typically, to drive autonomously, you don't need a Z direction because you don't have a flying autonomous vehicle. So that's why one dimension is kept weak in this LiDAR domain. So this is how information look like in real time. So these are the signals sent by the your car, and this particular car is sensing all the information around it, even from the back and whatever is the vehicle. You can see there are lot of blind spot behind the cars and all, but you just have to have a basic information about the object, and you may not consider what is there behind, because we are not here to visualize the object. We just want to see what should be my accelerator position and how much should be the steering position. So only two things need to be controlled to drive a car. And we don't even care about brake, because accelerator position itself can determine the speed, and that's why we care about the accelerator position. Another important sensor used with this is called ultrasonic sensor. Now, typical ultrasonic sensors you are seeing from many days for a parking sensors, and they are very inexpensive. So you get this particular beep when you are trying to go into the reverse direction, and if that beep's frequency goes on increasing as and when you are getting closer to the back, they are called parking sensors, and they are typically made up of ultrasound. The ultrasound sensors are available in market, starting range of rupees 200, and they have very good accuracy of around 4 meters. So you can see HCSR04 is one of the most popular ultrasound sensor, and this particular technology sends out the sound signal, which are again not in a audible human range frequency. So bat can hear this ultrasound, but we can't. And typically it is above 4 to 10 kilohertz. So you generally don't hear it. Sometimes you might get a very slight beeping sound, but those with a higher frequency range audible capture. So typically you get a very good information with ultrasound also. And here you can see a live video being matched with the all the data coming from LiDAR, radar, and even with your ultrasound sensor. And this is how it sees the obstacle as a block in front of it. And the free path is also estimated. So you can see a lot of things are happening in real time, and accordingly the acceleration, velocity, and the wheel steering angle is being controlled. So the typical ultrasound sensor also come with two particular frequency ranges. One is at 40 kilohertz, so it is way above our listening ability. We generally hear about 20 kilohertz, so it is more than double. And there are long range reflections ultrasound, which are around 48 kilohertz. So again, these are the transmitters, and they have a receiver. So typically they come in a pair like this, so transmitter receiver pair, and they are pretty visible also, and they do get damage over a period of time. So we generally install multiple of them, and using multiple of them also avoids any blind spots. So typically a car will have two sensors in the side. So one day when I was parking my car, there was a bike exactly in the center and none of my ultrasonic sensor gave me any indication. So I was just taking a reverse and I hit the bike, and then I realized that it was in the blind spot of a car. So these you cannot completely trust these sensors. You have to keep your eyes open while driving, and otherwise you have to install multiple of them. So to range of sensors that you can see onto your autonomous vehicles are ultrasound sensors, which we just talked about. Then imaging sensors do involve night vision camera. Then you have visible cameras, which also has a 360-degree camera. Then you have your 3D cameras, which are for the gesture recognition, or it can also give you the depth information. Then you have lidars. Typically a rotating lidar is used, but nowadays there is something called as solid state lidars. So SS lidars are upcoming technology, and basically here, instead of having a single rotating lidar with one array of transmitter receiver, it has multiple of them. A typical array of SSD consists of at least 6 different angles, and then it can get the information with a resolution of 120 laser lights in a single direction. So 6 into 128 data points are generated per second. So you can imagine the amount of data you are getting from the car, and this has a capacity to go up to millisecond also, based on the processor that you are installing inside a car. Then you have your different types of millimeter wave radars. So you have short range SR, medium range, then completely short range, then again short and medium range, and then you have a long range. Now, along with this, there is one more sensor which is very important. They are called dead choking sensors. They are the combination of gyroscope, accelerometer, speed pulses. That means you have a wheel, you have this particular grooves cut into this wheel, and then there is a transmitter receiver placed around this wheel to measure how fast the wheel is rotating. So there is one LED transmitter, there is one sensor, and how many times this LED light fall on the sensor. Based on that, it can determine the speed of a wheel. Then you also have a GPS sensor, or it is also called as global navigation system. It's a free system. If you have range with 3 satellites, you can guess your information onto the earth. You get your latitude, longitudes, and based on that, you can predict where you are. So typically, this dead rechoking is used for the turns. So whether you have to turn, it's not always best thing to turn at 90-degree. So with the cars, you are already at some speed and you cannot do this kind of turns. You have to pre-plan your turnings. So that's why you need all these sensors, and especially the gyro accelerometer. The typical unit is called IMU. It is called inertial measurement unit, and this kind of sensor will give you information about 3 things. The accelerometer will give you the information about X, Y, and Z, whereas the gyroscope will give you the information about rotation. That is, we call it elevation azimuth angle. And then you can also measure yaw and pitch. And then there is a magnetometer, which tells you where is the north. So based on that, with respect to North Pole, how much your car is actually getting turned, that also you can measure with this IMU sensor. So coming back to the all the sensors that we have over here, you have your long range radars, visible camera, 3D camera, night vision camera, a lidar, your short range radar, and you also have your dead rechoking sensors, or we generally call them as a odometry sensors. Now coming to the actual systems, you have your perception layer where all the data are coming from your cameras, lidars, radars. Then you actually have a CPU where all this data is collected, given to the GPU, where it applies a deep learning technology and gets the information back. And then you have also a dedicated algorithm burned onto the FPGA chip to have a speed that your general GPUs cannot give. So very fast computation is done through parallel processing FPGAs. Typical FPGA will have a cores around 128 parallel processors. So a GPU will have around 324 parallel processing cores, or even 512. Nowadays they have also gone up to 1024 processors. So you can imagine 1024 parallel computations it can do with a 32-bit depth or 64-bit depth. So amount of computation is not an issue, and at a clock speed of around 4 gigahertz. And then you have your final control. The control is typically only of two things. We generally control the steering and control the acceleration. So now where the all this deep learning, we talked about lot in a sensor. So let us now focus to the second part of this talk, where we call a deep learning used in autonomous car. So the main purpose is to take this enormous big data, what we call, process it and find where are the humans, how they are going to move around, okay, where are the cars, in which direction they are going, with what speed they are going. All this information needs to get gathered from the information from the sensors. You have your radar sensors, your camera sensors, you also have your GPS, and then you can't do this over a global platform. So you can't send all the data to your Google Colab and do the information processing and get the information back. So it all gels down to something called as edge computers. So edge computing is where you need to have a immediate decision, and especially if you have sudden red signal or suddenly a pedestrian come in between, you have to do a edge computing. You can't rely on a system that sends the data over a cloud and do all the complex processing with the massive servers that they have in the cloud and then send back you the data. That is not possible with the autonomous vehicle. So everything has to be done on the spot and within that particular time limit. So why not machine learning? Because typically machine learning requires an expert who can extract the features from the data. So it is basically a human saying that this is important, this is not important. Then you have a classification layer where you can decide whether it's a car in front of you or there is no car in front of you, something like that. Whereas in deep learning, you do everything using a convolution network, which can extract the features for you and classify on the spot. So you get rid of this human intervention over here. Obviously it will take longer. So one thing that machine learning can do with 100 images, deep learning needs to do that with 1 lakh images. So that is the kind of information you need. So basically deep learning can only be feasible if you have big data. If you have a very small set of data, there is likely that it will overfit that data and will not give accurate answers for a real-time information. So typically these networks are consisted, basically you can imagine an entire network to be a tuning knob. So each of them you can consider as a tuning knob, where we tune two things. What is the weight at this particular point that gets multiplied to your original information, and what is the bias that you add to the original information. So these are the two terms that we generally tune for each node, and based on the values that this particular W or B take, that decides what should be the output. Typical outputs are classifications, or they could be a multi-class classification, binary classification, where it just have to say yes or no. If it is multi-class, we have to say whether it's a car, whether it's a pedestrian, whether it's a cycle. And there is also third thing, which is called a soft decision, where we say it's a car with a probability of 95%, it's a pedestrian with probability of 40%, something like that. So it is not sure about what is the output, but it can tell you how much it is sure about it. So when it comes to the deep neural networks, we generally see a convolution network used, especially with the images. Convolution basically adds something where you see a block of data. If you remember your signal processing, convolution is nothing but shift, multiply and add. So it same operation is happening, but with that you can actually converge the information which is very important in that particular image. And once you convolve, you typically do a down conversion either by max pooling or averaging out the information. Max pooling is better suited, and then you take some non-linear multiplier, maybe ReLU layer, or there could be a SGDM layer. Based on that, you take a final decision between 0 and 1, and whether the next layer consider the previous layer or not. So there is something called as decision making, where we can say the convolution layer remain active or not. So based on that, you just keep on reducing the size of the information layer by layer, and you go on increasing the number of the filters taking those decisions, and finally you come to the fully connected layer. Once you have fully connected layer, here weight and bias of each path is important. So here you have all the nodes going to all the nodes to the next layer. So none of the information is missed over here. And then finally you can have a classification or softmax layer, where you can take some decisions based on whether it's a multi-class classification or not. Now, to train this autonomous vehicle, you might have seen, if you try to log in, you get this captcha. Yeah. So once you get this captcha, you are asked to determine, can you see a car in this, and you get 9 pictures, and then you have to select all the pictures with the cap. So this is where autonomous industry is getting information from the human, what human sees. So we think it is for our protection, like it is for our protection, those captures, but these visual captures are actually information gathering without your knowledge. So many a times they will ask you, can you see a bus in this picture? Or nowadays, now you can notice whether it is asking for a mountain or a road or a zebra crossing, and these kind of questions only will come to you. And these are the actual images captured by the autonomous systems, and they are collecting it from all the humans around the world, and this information is now getting used for the training of the autonomous vehicles. So typically this deep neural network, a GPU based processor. So there is a CAN network, controller area network, lot of processor and a lot of power being used. It has to be typically battery powered, so it cannot consume or lose any information in form of heat. So you need a superb cooling system for the GPUs. You get your environment information from the sensors, that is state and reward, and you give back the acceleration and braking or the throttle and the steering angle as an action back. And all this information is gathered as a state information from the host vehicle itself. So the information inside the car and the information from the surrounding. So both are fed as a separate part to the input layer. Then there is a network. Typically, any autonomous vehicle will have around 19 hidden layers, but you might see some of them has designed with 256 hidden layers in between. And the number of nodes in each layer can go up to even 5,000 also. So these are the typical kind of computations we do before we decide how much should be the throttle and what should be the steering angle wheel. So you can't have a infinite amount of data. So what we use is something called as GAN technology. So basically these are generative networks that can generate the information which is not there. So you can see from labels, it can generate the information like actual car, or if you draw some drawings, it can generate how it will look like in real life. Or even if you have black and white image, it can see how it will look like in a color. And even you can do a reverse way around, where you have a satellite image, it can find the roads. You have a day image, it can find a night image. And even with hand drawn pictures, it can draw you the actual information. So these are a very powerful information networks which you might use to get the information. I told you around 1 lakh piece of information to train any deep neural network, and you can't get this kind of information in a day. So you need to use GANs. And these are done offline, so you don't need edge computers to apply a CGAN onto the car. So these are some of the faces which are completely made up. They are done through a GAN network. Most of the cars do use something called as deep reinforcement learning. So if your decision is correct, it is given an award, and if the decision is wrong, it is punished. So this is kind of reinforcement learning, and deep reinforcement learning ensures that none of the trained deep neural network remains like that. On every bad decision, it retrains itself. On every good decision, it strengthens its score, and as long as your score is good, you're not retrained. So this is how a kind of real-time deep learning output will look like. So this is detecting as SUV. So even not just a car, it can determine what kind of car. If it is a police car, it can give it more priority. Ambulance also have a special priority. And the basically deep learning not only detects the type, it can also do the segmentation, which is another important roads required to do all this autonomous work. So currently, I can clearly say that autonomous cars is for the developed countries, and for the countries like India, you can't have this solid lines all over the place. People are not building such kind of roads, and that is a bigger problem. And that's why for developing nations, this is absolutely what you can say impossible task to do autonomous driving in India. But maybe a decade later, things might change. We have some highways which has this kind of things, so we might see autonomous driving in some parts of India, may not be throughout India. So here are some of the tasks that AI based neural network can do. Perception and localization tasks, where it sees the objects and determines what they are. Then it has a high level path planning. So I want to go from location A to location B, let's say Thane to Pune. So this is the kind of path planning through Google Maps it will do. What is the best path? Where is the traffic? Then it will have a behavioral attribution. You can see that suddenly this truck is going very slow and I need to overtake. So I might have to change the lane, go ahead. Based on that, I should calculate the things. And then also I need a motion controller. So whenever I say I want to move my car by 3 degrees, because of the environmental wind, sleep on the road, might be your tire friction, it might not get that 3 degree. So you continuously need a motion controller, and based on your actual position and the position you need, you have to redo the calibration with the steering angle and accelerator. So this is the expected output in real time. You can see that there are 3 cameras mounted on a car, and it is doing all the detection in real time. So this is the kind of speed that we expect a deep neural network should able to do. So अभी हम क्या देख रहे हैं, deep neural network है which can do all these things on a static image. That's great. It can do all these things on a static image with 99% accuracy. That's even great. But now we need something which can do it at 99 or 100% accuracy, but within a millisecond, which is not right now possible. You can see people training their deep neural network for 3 days, 4 days, and after that they are getting the results in 7 minutes or 6 minutes. But we need few milliseconds to make those decisions. So to train the network, obviously you can't take your car and reach the people's life. So people do have built this kind of simulators. They are basically a video game, and you have to train your video game to drive autonomously. So a Carla simulator is one of the most popular and free simulator available to train your deep neural network. This is how the environment will look like, and based on that you can create any environment in Unity and import it to Carla, and then you can start training. So if you have real life photos of Mumbai, you can put your area into this Carla simulator, and it will start building a autonomous vehicle algorithm for it. So we have to build the code. It supports Python programming, C++, I think C# is also supported, Java, and I think it supports Kotlin also. So these are the different types of languages you can use. Then you have your Udacity, which is one of the online training platform. They have their own autonomous training module. So here they have done an interesting thing. Instead of just asking you to train, they will ask you to play. So that is where they monitor how human is driving. So basically they record what steering angle you kept, how much acceleration you give, and based on that they collect all the data, and then they go to the autonomous vehicle and they compare what is your actual data, what you did, and how is your algorithm is giving the output, and based on that the final decision can be taken. You can also select the type of the tracks, and you can see the live output over here. It supports regular Linux or Windows platform both, and live outputs you can see uh, with the accuracy, and you can see this as a third person or a first person, and you actually get all the information from this car's lidar, this car's cameras, and this car's ultrasonic sensor. This car has a radar sensor, so you get actual data from this based on your virtual environment, and then you have to do all the coding to get your car running. So typical speed ranges has reached up to 58 mph on class 5 autonomy. I think that is a record last year. We expect you to reach around 80 mph. So kilometers it might be above 100 kilometer per hour. So this is the kind of speed people expect you to reach. And is this kind of simulators do require a GPU based computers. So typical GPU based computers, at least 4 GB GPU need, and you can have 16 GB of RAM. So I think this is a video from NVIDIA's car simulator. I think I have shared the audio. I'm not sure about it, but this is how a simulator will look like. So it's a tunnel through which this car is going, and quite realistic information they have given, at least for USS San Jose area. But you can see that it has quite realistic graphics, and everything is like this only. They are created from actual moving the car and getting the information in 3D, and then that information has been recalibrated using a Unity platform. So this is all getting self-driven. There is no human controlling this car. It's all controlled by program, and other cars are controlled by computer. So they do a random behavior like actual cars would do. It also detects the stop sign, the signals, and also try to follow all the rules. So what is the bigger picture of this? Basically, we try to avoid all the accidents. You can imagine an autonomous car can travel you safely without any traffic. So you can reach from one destination to other within a less time, and you can do more productive work. So these are nothing but robots that are carrying you around. And this is the one of the outputs where you can see a proper edge detection has been employed. So segmentation, edge detection, object recognition, classification, all such tasks are required to be done using a deep learning. And so this is the case where there is one guy called Elon Musk, who is the owner of the Tesla. He said his car Tesla doesn't need a lidar, and he removed the lidar from his car. And what he's saying is, if human can do with these two eyes, all your autonomous car needs is two cameras, which is technically kind of correct, but this is what has happened to the car. So this is a truck falling on a road, and what has happened is the vehicle did not recognize this truck at all, which even a simple sensor like lidar radar could have done. So what happened is his cameras failed, and it just got hit by that. You can see that car did not stop at all. And what could have been a easiest task for a human could not be achieved by the fanciest machine like Tesla car. So what actually has happened is, out of the two cameras, one camera failed to give the information, and that's where the stereo vision failed. And then there was one fellow who has created a confusion in Tesla cars computing system. You can see this fellow around here. So this fellow actually created the confusion, and then this car was going straight. It miscalculated and gone into the hitting the truck. And this was not a regular vehicle pattern. When they have trained the machine, they have not put trucks like that horizontally across the road. So car did not assume that anything is wrong over there. And obviously for camera, it was seeing a flat white region. So it assumed that it's a plain road, maybe uphill, but it's the straight plain road. And that has caused this kind of this accident. So this is always a ambiguity. If your car is seeing a green signal, but it is also seeing a human, it should always give a priority of stopping the car and not allowing one decision overrule the other. So safety should be the most important decision for the car. And you can see some of the accidents that has happened in recent 2 3 years. This car has crashed, so you say that is not a big thing, but then you can see a car has flipped, and it has also broken lakhs and lakhs rupees lidar. It has also damaged the other car. Then you see a famous Weibo, one of the big brands, Google's big brand, uh, getting hit, and deadlier accident has happened. So we say all this technology, robots, they are very good, but actually it is also very dangerous to leave the powerful robots of so many horsepower on the road and nobody is monitoring them. So this is the 2018 case which has given a huge setback to this autonomous vehicle, where this car, Uber, I think is the company, has killed a lady on a cycle. And this is the first death happened ever with a autonomous vehicle. So because of this case, most of the autonomous projects were shut down. And at least nowadays, only 7 to 8 companies are still running these kind of process. But I think these kind of setbacks are expected. I think not only this particular lady who was really unfortunate, but you will see at least 1000 more cases where autonomous cars are killing human before you see this technology grow to its potential. And with that, this last video, I will leave you with the real vehicle by NVIDIA driving around a route in California, and you can see how easily this particular thing can drive itself. So with that, I will stop, and this is the actual information being captured in real time. So NVIDIA is one of the big players in autonomous vehicles because of their GPU power, and they have built this particular scenario in their VR, and then now they are actually testing it in real time. So yeah, that's it from my talk. And if you have any questions, I will be happy to answer them.